Now that you have your ocean map created, this is showing us the profile of the ocean floor. And this was new information for us in the 1950s. We hadn't seen this before. We weren't able to explore it. We certainly didn't have the technology to go diving deep into these oceans like this. But after World War II, where submarines were using sonar and sending back this data for us, we could actually map the ocean floor and see that there was great elevation changes happening throughout the whole ocean floor. And on your map of the Atlantic Ocean, now make sure you're going to the Atlantic Ocean. I want you to add these labels on here. You can go ahead and pause your screen afterwards, but the first area that gets more shallow is called the continental shelf. And immediately that descends into the continental slope, which is pretty steep. At the bottom of that slope, we see where the continent starts to rise up from the ocean floor, and we call that the continental rise. Now, there's an area of the ocean floor which is pretty deep. Notice we're about 4,000 feet deep, and it's very flat. And this is called the abyssal plains. Just like the plains out in the Midwest, the abyssal refers to being very deep, and the plains just that it's very flat. And then all of a sudden, some of you might have freaked out while drawing. That's like, oh my gosh, am I doing this correctly? Yes, you have a volcanic island that over many, many years has built up. Magma has solidified to create new igneous rock, which has peaked up over the surface and has created an island. And then it gets deep really quickly again, another abyssal plains. And then we have this area which was really new for us and unexpected, but these two peaks, they were about the same size on either side, and in between them, a rift valley. And this was found in the middle of the ocean. When you look on a map of elevation, you can actually see this area in the middle of the Atlantic Ocean that has a higher elevation. It's still underwater, and we know that based on the key on the side here that shows that anything light blue is underwater still, but higher elevation. And we can see that long mountain range right there. That's the mid-ocean ridge, the mid-Atlantic ridge, and it's the longest mountain range in the world. That was a new finding for us. It was, as some might say, earth-shattering, if you get my pun there, because that's actually a diverging boundary right there. And that was new information that helped support the theory of plate tectonics. In addition to seeing this mountain range on the elevation map, they also noticed, once they started doing radiometric dating on the rocks, that the youngest rocks were in this area too. And that as they got out toward the shores, toward the coastline of North America and Africa, they noticed that the rocks were actually getting older. And so in the middle of the ocean was the youngest rock. Near the coastlines was the oldest rock. In addition, they discovered there were shallow earthquakes happening along this area, and there were some volcanoes. Not a lot, but there could be some volcanoes happening along that. You are going to have to start and stop on this video in order to make sure that your map is colored correctly. I'm going to walk you through how to color your map with that data that we saw on the maps, the data maps. And so on your large Atlantic Ocean map, we're going to color code the ocean floor, anything below this blue line, with the age of the seafloor. And we're kind of using this map as our guide so that we know that in the middle where the mid-Atlantic ridge is, that was the youngest seafloor. We're going to color that red, and I apologize, I couldn't figure out how to do that quickly on here, but go ahead and color this area, the middle ocean ridges in the Rift Valley. That's red. That symbolizes that this is new crust being created. And you can pause any times to give yourself a chance to color these in. Next to that, we have slightly older rock, and so that is colored orange. Then we have yellow. But this volcanic island, this is actually getting to be younger rock, right? Like over time, that volcano is creating new land, which is higher up. So I'm actually going to color orange, and then it turns into red at the top because that's the newest. And then as we move closer to, let's say, North America, just like in this image up above, it is going to become older. Green represents 90 million years. And then our oldest ocean floor, about 180 million years ago, is blue. And that actually tells us that perhaps if we look on this big map here, those continents were closer together, and about 200 million years ago, they started to separate. And so our oldest ocean floor that once was in the middle is about 180 million years old. I did not do this on my screen, but you should create a key on the side of your map so that you know what these colors represent. Now, we talked about how there were also earthquakes happening all along this mid-ocean ridge. I'm going to symbolize that by putting an earthquake symbol here and creating an E on this side. And then I'm also going to create a volcano because I did see some volcanoes and I made a little symbol here. You can create a mountain, but this was my volcano symbol. Our map is complete. Since we believe that this mid-ocean ridge is showing the boundary between two plates, I want you to draw an actual boundary line on your data map. And you will see I just added a dotted line in between the ridges in the Rift Valley. So go ahead and draw a dotted line, or just a solid black line is fine, but that's going to symbolize our boundary, the area between two plates. Label that a divergent boundary. That name is really important and it tells us which direction the plates are moving. Just like in math class, when you see the word divide, and that means usually to split something, this is what's happening on this boundary where the two plates are splitting apart from each other. This is where we can draw two arrows to symbolize that the plates are moving in opposite directions. They're dividing. And we have named this side the North American plate. And on the east side, we call that the Eurasian plate because it's holding Europe and Asia. So go ahead and label your boundary as a divergent boundary, include your arrows on either side, and then add the plate names so that you know which plates are coming together at the Mid-Atlantic Ridge.